All right, welcome to math today. We're going to be in our third lesson of this unit. Our quiz will be coming up after this lesson. Here's our goal today, to write expressions between tables and sequences. We're going to be looking for patterns today. That's what I want us to practice. So once you have today's date, page number, and goal written down, you can move on. Here's what I mean by patterns. Let's start in the warm-up by trying to find the pattern here. And then see if you can figure out what it is you had to do to each number to figure out the correct value on each line. Good luck. Here are the answers you should have seen. So for number 1, I added 3 to each one. That's how I got 19, 22, and 25. For 2, I subtracted 17 from each one. And for 3, we multiplied by 2. This is exactly what we're going to kind of work on today, to look for patterns in numbers and try to see if we can find patterns between two sets of numbers. Let's get started by looking at a scenario. All right, so here we're looking at international chess master Andrew Martin. Not really, that's a picture. Back in 2004, broke a world record by being able to play 321 games at one time. Well, if each game requires 32 pieces, how many total pieces would he actually need to use? If we started to create a table, we could start to look for a pattern. So we know with one game it would be 32 pieces, 2 games would be 64 pieces, 3 games would be 96 pieces. So how do you get from games to pieces? You probably recognize that you multiply by 32. So if you're multiplying by 32, you're going to write an expression that says 32n, which means 32 times n. And what does n stand for? N stands for games. So no matter how many games there are, you know you're going to have to multiply 32 to figure out how many pieces were in the game. So if you want to earn a little something from me, go ahead and figure out the answer of how many chess pieces that would be for 321 games. And if you're correct, come show me. So if we look here at this problem, we have to start looking for a pattern. Now if we look here at the pattern between Spike and Rusty's age, you can see we go from 2 to 6, 3 to 7, 4 to 8, and then we have the variable a down there for Spike, basically saying any number after 4, what's Rusty's age going to be? So you have to look for patterns. And here's where you use one of your 4 operations: adding, subtracting, multiplying, and dividing. Do you see a pattern how to get from 2 to 6? Well, you can either do 2 times 3, which gets you 6. You could do 2 plus 4 and get you 6. You can't really do any subtraction because it's a larger number. And you can't really divide to be able to get to 6. So what you did see, though, is that if you add 4 to every single one, you end up with the right answer for Rusty's age. 2 plus 4 gets you 6. 3 plus 4 gets you 7. 4 plus 4 gets you 8. So the pattern we're actually looking at here is that no matter what Rusty's age is, or I'm sorry, whatever Spike's age is, you just have to add 4. So in that box, you would include to say that Rusty's age is a plus 4. And it's okay to leave it as a plus 4 because then it means we can put in any single age of Spike's and we would always know what Rusty's age is. So if they get really old and someone says, hey, Spike, you're 54 years old, how old is Rusty? If you add 4, you get 58. So go ahead and put this table down and make sure you put the answer at the bottom there as well. Let's look at another example. Here's another one where you're looking for a pattern. If you want to pause the video and see if you can figure out the pattern before going through it, go ahead and give it a shot. Again, we're looking for an operation or some sort of math formula of how we can get from 1 to 7, 2 to 14, and 3 to 21. So you could start by adding, and you see that 1 plus 6 gets you 7. But can you do 2 plus 6 to get 14? No. So what's the next operation where you go from a small to a big number? That'd be multiplication. 1 times what gets you 7? 7. That's the identity property, you know that. 2 times 7 would get you 14, and so on. So you found the pattern here. All you have to do is take Ty's age and multiply it by 7. So if Ty is 3, Rich is 21, so A times what gets you Rich's age? The answer is 7A, or A times 7. So if you know anything about ages in certain breeds of creatures, uh, dogs age at a speed of 7 times humans. So I'm going to guess Ty is a boy and Rich is the dog. So 7A is the pattern. Now, I want you to try this one on your own and then come back. We'll see if you got it right. You're looking for an expression for wheels for N go-karts. So look for the pattern. How do you get from 1 to 4, 2 to 8, 3 to 12, and 4 to 16 equally? Come back when you're done. All right, so what you probably saw is to go from 1 to 4, you can't add. It's inconsistent when you get to 2 to 8. But you probably did notice that you're going to multiply by 4 every one. So you probably got 4n, or n times 4, n times 4, or you could have done 4 parentheses n. All those are the correct answer for how to get from go-kart to wheels. That's your answer. Again, it's not an actual number. It's an expression, a sentence without an equal sign that explains what you can do for any possible number that you're given. Let's look here at practice 2. Sometimes your sequences are going to need multiple steps to be able to figure it out. So let's say you're looking for a relationship here between the positions and the values. So whatever position you're in, how much is it worth? So you first have to start using some guess and check. So how do you get from 1 to 7? You have to think what operation gets you up higher. You could add 1 plus 6, then try it on the next one. 2 plus 6, it's not going to get you 10. So now you try multiplying. 1 times 7. Try 2 times 7. You find that's not going to work. So now you have to be a little creative. You know that you can multiply smaller numbers than 7 to get you close to 7 and then add up, or you can multiply larger than 7 and subtract down in equal terms to make sure it works. Well, here's kind of how you can figure it out. The correct answer is in the blue. You can guess 3n plus 4. We already tried 7n, 7 times n, and we found that whatever position is of n, if you multiply by 7, it's not going to work every time. But if we took any of those positions, 1, 2, 3, or 4, and we multiplied it by 3, and then added up till we got to where we needed, which is 4, it works every time. 2 times 3 gave you 6, plus 4 gave you 10. 3 times 3 gave you 9, plus 4 gave you 13. 4 times 3 gave you 12, plus 4 gave you 16. You got to find a pattern that is consistent every time. So the correct answer for the value is 3n plus 4, which means 3 times n plus 4. If you need to write this example down, go ahead and do so. All right, try this one. I'll give you a second box to try to figure out. This may need 1 step. It may need 2 steps. See if you can find a consistent pattern, whatever it is, that whatever you do to n, you're going to get the value here. Good luck. I hope you noticed that for this one, it was n, and you just added 8 to each one. So you added 8 here, you added 8 here, you added 8 here, and so on and so on. And the answer, okay, there it is. The answer here is n plus 8. So actually this one only needed a 1-step process to be able to figure it out. Now here's another example, and this is our last practice of the day, where writing an expression for area could be used. So we used area in the last problem, or the last lesson, to figure out how to write the expression or use the expression. Here we can make an expression. So this triangle shows in the box that the base is consistent every single time. The base is always 6 inches. The heights, however, change. So how could you write a formula or find a formula that would work every single time? Well, you have to look for a pattern. 6 to 1, well, that means you can multiply 6 times 1 and then divide by 2 to get 3. 6 times 1 gets you 6, divided by 2 gets you 6. I don't know. Maybe you see the pattern. But the big thing you should be able to identify There, we're back on track. You should be able to identify that what you have to do is multiply the base by 6 and then divide by 2 for each height. So basically, all you have to do for this one is see that you're going to do 3 times whatever the height is. You don't have to worry about the base. It's just multiplying the height by 3 to get your answer. You don't have to write this one down unless you want to. But I do want you to try this one. So see if you can find what the area is here. If we have a rectangle that's length is 5 and width is 2, 4, 6, or 8, or W, whatever we can use. Good luck with this one. Come back when you're done. All right, so for this one, you're looking for a pattern to go left to right. And what you probably noticed is all you have to do is take the width and multiply it by 5, or 5 times W will always give you the area. Because if you did 2 times 5, you got 10. 5 times 4, you got 20. 5 times 6, you got 30. 5 times 8 and 40. So on and so on. All you have to do from here out is multiply all the W's, the widths, by 5. Hopefully you got that as the correct answer. All right, here's your box of thought. I want you to try these two with full sentences again in your notebook, and then box them off when you're done, and then move on. Here is your quiz. You got 3 questions. Remember, you're not giving me a number for an answer. You're giving me an expression, a pattern on how to solve Scott's age to Ray's age, or the position over the value, or here, what's the area if your width is 7 and your length changes. Good luck. See you next time.